All right, so here we are with the 7-2 Day 2 assignment for pre-calc, and we're starting with number 29. So taking a look in our textbook here, the first thing is that we are solving for A and B. So there are these empty pieces in number 29 and 31 that have an A and a B instead, and you are going to figure out how you can make these two equal. So remember that in a matrix, we are talking about each of the upper and lower pieces that should be equal. So really, 5 should just be your A value, and then the missing piece here, since 4 and -3 match, is that B is 2. So not a huge discrepancy on how you might solve that, but in number 29, A is going to equal, again, its same place value, so 5, and 2 is going to equal B. All right. Then in number 31, it gets a little bit more complicated. So now instead of just equaling, they equal, but we have to algebraically solve. So now we're going to get this upper right here piece that's going to equal -3, and then this middle left piece here that will equal this piece to find A and B. So in number 31, in order to find A, again, we are going to take that upper right piece, which was A minus 1, and set it equal to the other matrix's upper right piece, which is -3. And then we'll do our little algebra to solve that and get an A of -2. Then the other one has your middle left piece, so B plus 2, and that's going to equal the other middle left piece, which is 2. So we'll solve by subtracting 2, and now our B is 0. All right, so those are the two answers for that piece. All right, and we're moving on to number 33. In 33, we need to verify that the matrices are inverses of each other, and remember that there were a few ways of doing that, one of them on calculator, or 2 of them on calculator, and then the other by hand. So I'm just going to do the one by hand to make sure that we remember how to do it. But the idea is that I will multiply A times B, and hopefully I will get the identity matrix. So in number 33, to verify, I'm going to multiply A times B, and hopefully that will equal the identity matrix. So the matrix of A is, let's see, where are we? 2, 1, 3, 4. And then we're going to multiply that by B, and the B matrix is 0.8, -0.2, -0.6, and 0.4. And remember that once we multiply those, hopefully that will equal the identity matrix, and the identity matrix has 1s on that diagonal and 0s on the other. All right, so algebraically, that means that we're going to do 2 times this row, so 0.8, plus 1 times this bottom part of the row, so -0.6, and then 2 times this column, so -0.2, and add that to 1 times 0.4. And then we'll do 3 times this column, so 3 times 0.8, and then its second piece, 4 times -0.6, and then the same row, but now times the next column, and 4 times 0.4. So again, we want to get all these 1s here. So our mid step here is that 2 times 0.8 is 1.6. And then we're going to be subtracting 0.6 from that. So hopefully you can see that that will result in a 1. Then the next piece has -0.4 from this multiplication, and we're going to add that to 0.4. So again, you can reference that that would become 0. Then 3 times 0.8 is going to make 2.4, and we're going to subtract 4 times 0.6, which is also 2.4, and so we'll get a 0. And then this last piece here, negative 0.6 for this first piece, and then that's going to be added to 1.6, so we'll get 1. So because that's your identity matrix, A and B are inverses. Remember that you could have done it on your calculator by multiplying A times B, or you could have done A inverse on the calculator as we did in the notes piece, and just verify that that's going to be the B matrix, which is the result from our notes one. All right. So then we move on to number 35. And number 35 wants you to find the inverse matrix if it has one, or state that the inverse does not exist. So remember that if the inverse doesn't exist, the determinant is equal to 0. So we can go ahead in number 35 and figure out the determinant. And remember, you can do this by hand or you can do it on your calculator. So I'll just do it by hand and verify with my calculator. So our matrix is 2 with a 2 and a 3 and a 2. And if we want to find the determinant, that is going to take 2 times 2 and subtract 3 times 2. So that first diagonal minus that second diagonal. So 4 minus 6, as long as that is not 0, which it's not because it's negative 2, that means that an inverse exists. So then continuing in number 35, we're going to actually find that inverse. And so we're going to take 1 over this determinant, which is negative 2, and multiply it by, remember, we need to flip these two, so not really a whole lot of movement there. It's going to be 2 and 2. And then make both of these in their same place, but the opposite symbol. So negative 3 and then negative 2. And then we will multiply this in just like it's a scalar. And so we're going to get 2 over negative 2, negative 3 over negative 2, negative 2 over negative 2, and then 2 over negative 2. But of course we want to simplify as much as possible. So in that case, we'll have negative 1 as part of the inverse. Positive 3 halves, so we'll just call that 1.5. A positive 1 for negative 2 over negative 2, and then a negative 1 for this other piece. So this is your inverse matrix. And again, maybe depending on if it was faster or not, you could go to your matrix, edit matrix A, because that's the first one we're using. Make it a 2 by 2, which it already was. Fill in 2, 3, then 2, and 2. So again, the original matrix that we had, 2, 3, 2, and 2. Go back to the home screen. Recall your name of A and do its inverse. And of course, if it didn't have an inverse that existed, it would tell you that the inverse doesn't exist. So either with an error or some text. All right, moving on to number 37, same grouping here. It says to find the inverse of the matrix if it has one, or state that the inverse does not exist. So in number 37 here, we have a 3 by 3, which means I'm not going to be doing it by hand because otherwise we'd be here all day. So instead, in number 37, I will take the time to find the determinant. So the determinant value of what we have here going to our matrix and editing it so now we can plug in the 3 by 3 that is part of the problem. We have 1, 2, and -1 as our first row, 2, -1, and 3 as our second row, and 3, 1, and 2 as our last row. So double checking that that is what I should have entered. All right, and then we go to the math operations, and I can find the determinant. And so I'm finding the determinant of my new A that I just put in. And again, if this is 0, that means that the inverse doesn't exist. And so in that case, I know that it's 0, which means the inverse does not exist. But just to double check that it doesn't, you can go to A and then try to do its inverse, and we'll see that the calculator says singular mat, which is going for singular matrix. So either way, that means that a determinant, or sorry, an inverse does not exist. So again, the calculator language is going to be an error, and it's going to say singular mat. You can either quit, which would just go back to the home screen, or you can actually go to, which just means that it's going to allow you to type over what you just put in. So if you wanted to, oops, I meant to say plus or minus or something. So, all right. Then we have number 39 going all the way to 43 on this assignment. So in number 39, no directions. Or wait, maybe inverse matrix if it has one. Okay. So in number 39, we have matrix A, which has Aij as its elements. Aij is going to come from -1 to the I plus j, and I is going to be between 1 and 4, and j is going to be between 1 and 4. And so in order to get each element, we need to take each of its row and column values and add them and have them as a -1 of its base. So that is intense. So here we go. Basically, it's telling you that you have a 4 by 4 matrix because of the higher number being 4. And then I'm not going to put the other piece. And in order to get each of these elements, remember that this element right here was element 1, 1. So because that has an I of 1 and a j of 1, the formula is telling you that you need to take -1 and raise it to these two numbers being added. All right, so that's going to be our first element. Our second element, remember, our rows and then columns. So we're in row 1, but column 2 means that we would have -1 to the 1 plus 2. The next piece is going to be A13, which means we're taking -1 and raising it to the 1 plus 3. And then the last piece of this row is going to be 1, 4, which means that we're taking -1 and raising it to the 1 plus 4. So again, you're just inputting the I and the j, which is the row and column number. So you would do that for all the rest of them. And so this next one is going to be -1 to the 2 for its row plus 1 for its column. Then we've got -1 to the 2 plus 2, -1 to the 2 plus 3, and -1 to the 2 plus 4. And so hopefully you can see that this is actually going to result in kind of an every other pattern, because notice this is to an even power, which means it's going to become a positive 1. This is to an odd power, so it's going to become odd power, and so it's going to become an odd still. But I will complete this. So -1 to the 3 plus 1, -1 to the 3 plus 2, -1 to the 3 plus 3, and -1 to the 3 plus 4. And then the pattern continues, but now it's 4 plus 1, 4 plus 2, 4 plus 3, and 4, oh, that's a negative 1 to the 4 plus 4. So again, each of these in this case is an even power, so positive 1, but then odd. So it's going to go positive 1, negative 1, positive 1, negative 1. And then negative 1, positive 1, negative 1, positive 1, and then back again, positive 1, negative 1. So in our system here, we're going to have a positive 1, negative 1, positive 1, negative 1. Then it flips, negative 1, positive 1, negative 1, positive 1. Flips again. And last time. So this is the matrix that comes from what we were talking about in number 39. So remember that matrix A here, we are trying to use the rules here from this one, from 35 to 40, and we need to find the inverse if it has one. So if we're going to find the inverse of this, that means that we want to see if the determinant of this A matrix is equal to 0 or not. So if we're calling this our A matrix. So this is a 4 by 4. And again, not necessarily possible by hand at this moment. So we are going to edit matrix A, make it our 4 by 4, and start plugging in our 1s. And negative 1, 1, negative 1, 1. And okay. So hopefully I put that in. Here's our last column, negative 1, 1, negative 1, 1. Third column, 1, negative 1, 1, negative 1. First column, 1, negative 1, 1, negative 1. And then our second column. All right, so I have all those pieces in, which means that I can go to the math column of matrix and find my determinant of matrix A. And so notice that it is 0. And so it does equal 0. So the determinant is, whoops, I like how I just spelled is with an I and E at the end, okay? So there is no inverse. Okay. All right. So that's number 39. Then we move on to number 41. In number 41 and 42, we're supposed to use the definition to evaluate the determinant of the matrix. So I believe that would mean use the formula, and I suppose we could sit here and do that, but because the notes had us do it in the calculator, we will go ahead and do it with the calculator. So in number 41, we are trying to find the determinant of the matrix. And again, we're doing it with your calculator. And so we have to input this super fun matrix, which is a 3 by 3. So we're going to edit it and make it a 3 by 3 and input each of the pieces. So 2, 1, and 1, negative 1, 0, 2, and 1, 3, negative 1. See if I missed any of those. Nope. And so now I can find my determinant. And if you, again, are really fond of typing this in all the time, you can go to your second entry since I just did the determinant of the previous one. And so second and then enter would get your entry. And then it will do it for our new matrix A. So turns out that it's negative 14, and that's all I wanted was the determinant. All right, and then we have number 43. And so our last problem here is saying we need to solve for x. So they're saying 3 times some matrix x plus A is going to equal B. And so let's take a second here to determine what they are saying. So 3 times x plus A equals B. And so if we want to find this matrix A, the first thing, X, first thing we're going to do is move this A over by subtracting it. Once we subtract those two matrices, then we will divide by a 3 to these matrices, or multiply by a third, and then we'll have our X matrix. So again, algebraically, this means that we are going to subtract matrix A from matrix B and be left with 3 times matrix X equals B minus A, whatever that matrix ends up being. And then to undo 3 times something, we are going to multiply both sides by 1/3. And remember, with a matrix, that's called a scalar, but either way. Again, we can't necessarily divide matrices by a number, but we can multiply by its inverse, which is 1/3. And so that'll cancel this, and we'll note that our matrix X comes from a third times matrix B minus matrix A. And so we want to find out what matrix X is. And since we're over here with a 2 by 1 and a 2 by 1, our result is going to be a 2 by 1 because we're not necessarily multiplying any of the matrices. So we need to solve this, and it's probably easiest to just use our calculator versus to plug it all in. So first thing I'm going to do is edit my A matrix to look like the one in the book. So my A matrix is going to be a 2 by 1 with 1 and 3 as its pieces. So it's a 2 by 1 matrix, matrix A, with a 1 by 6 is what I typed, but it should be a 3. So let's type 3 instead. All right, then our other matrix, going to edit again, but now down to B, is also a 2 by 1. And we want to plug in a 4 and a 2. All right, so if we go back to the home screen again, we are not finding determinant anymore. We are now going to put in basically this operation that we said earlier. So we're going to do B minus A, which means that we're going to take the name of B and subtract the name of A. And then from there, we're going to multiply the result times 1/3. So technically we could just see how to do that because it would become a 1 and a negative 1/3, but we can have the calculator do it as well. So 1 and negative 1/3 is our result of our X matrix there. So X becomes 1 and negative 1/3. So hopefully that algebra makes sense of how we would do that if that was just an X, but notice that they are writing it as a capital X, and that's because it's actually a matrix that has variables in it versus just a lowercase x, which would be just a number. Alrighty, so that was your 7-2 day 2 assignment through 43. So hopefully that made sense.